Kara Yopak, a member of Colin's research team, gets
Hello.
inside the shark's head, literally, to find out.
When you look at a brain,
Hello.
you can make fairly good predictions about what that animal's eating, how fast it's swimming, the general environment that it's living in. This is the brain of a great hammerhead shark.
Hammerheads are open ocean predators, living along the continental shelf in tropical and warm temperate seas worldwide. They feed mostly on fish.
Its regions for the brain for vision are actually not very large. This is likely not to be a very visual animal.
Hammerheads rely on other senses, like electroreception, to target their prey. More
Rituals. Whereas in the great white, that region of the brain is not very pronounced, which leads us to believe that the great white is in fact a solitary hunter.
There's another conspicuous difference between the brains of these two species.
A lot of people are really surprised when they see the brain of a great white, particularly in comparison to the hammerhead, because it sensory systems, but the relative importance of each of those systems is going to be varied between species.
The great white shark attacks in Western Australia were an unusual series of events. Colin and other shark researchers want to know what factors could have triggered the attacks, and if there's a way to stop sharks before they bite. Sean Collin is here in Shark Bay, Western Australia, to test shark deterrents that are already available to the public, and new ones he and his team are developing.
We've worked on lots of smaller sharks in our laboratory tanks at the university, but we've got to make that progression from the lab to the wild.
These metal frames are designed to hold a bait canister to attract sharks, along with the shark deterrent to be tested, and a pair of cameras.
The idea of having two cameras is that we've got two different perspectives on the behaviour of the sharks.
Colin's team preps the first test with a device that emits an electric field, powerful enough to shock a human if the electrode is touched.
This type of deterrent has a long electrode, which is this lead here, which extends a couple of metres, typically behind a diver or the wearer, and once turned on, creates quite an extensive and fairly strong electric field around the device. This is the other type of commercially available electric device that we're going to be testing. It's an anklet-style device, again worn by divers or swimmers.
Bait canisters are filled with a mixture of smelly, bloody ground fish. And the electro-repellent rigs are deployed. Each rig is anchored to the bottom and suspended in the water column by floats.
No, everyone's going to bed.
They'll be left for 2 to 3 hours, enough time, they hope, for the bait to attract a shark. This is what happens when these rigs are deployed without deterrents. Bites that would inflict serious wounds. But which will be stronger, the scent of food or the electric deterrent? While the frequency of some electric fields seem to repel sharks, others attract them. So, which frequencies make animals into targets? And which might protect us? Ryan Kempster has developed techniques in the lab to find out. Bamboo sharks, small and easily kept, hunt for prey hiding under the sand, given away by the electrical impulses of their muscles.
So we know that all organisms give off bioelectric fields, and these can essentially be measured.
With every muscle movement, even the beating of a heart, an electric field is generated.
The actual size of the organism itself determines how far that electric field extends in the waveform. So, a larger animal is going to give off a larger electric field.
With electrodes attached to this acrylic plate, which he buries under the sand, Kempster simulates the tiny electric field of the shark's prey, a small crustacean or fish. With a camera mounted above the tank, he records when the shark bites at the electrodes, indicating it has sensed the electric field. So just how sensitive is the bamboo shark's electroreception?
You hear the little
They can
tooth, babe.
sense down to around about 1
What?
nanovolt.
See this tooth?
No.
Actually, this is a billionth
No.
of a volt. So it's an incredibly low electric field. So they're
Ashton, can you move,
really
please?
Very sensitive to the bioelectric fields of potential prey.
Back on Shark Bay, the team tests other deterrents based on their research into shark vision. This one is a flashing light. They'll transfer the camera's footage to the computers to watch later.
Good day. Here's the cameras from rig 27. This is the strobe lights.
Oh, brilliant. See if we've had some luck this time.
Brad,
Yeah.
go get off that now.
Why?
You've got to take the bins out.
Can I just do this quick?
In the meantime, they've got another deterrent to test. Scientifically designed patterns for wetsuits.
This is designed to be camouflaged underwater, certainly to the visual system of a shark.
Yep.
As Colin and Hart discovered, sharks are colorblind. They see the world in shades of black and white. This material is designed to fade into the background as the light changes at different depths, each color tailored to what a shark's eye sees.
So the idea is to
I know, I'm coming off it!
Now, I'm really getting pissed
A
off.
second design
Don't you?
That's the wire out of your PS4.
Alright! You're not touching my PS, or you're paying for a new one.
I can't breathe.
Yes, you can, it's just him.
You've got your own bedroom.
You told me I was allowed
You've
it down.
had it down here for 2 hours.
No, I haven't. Not 2 hours. No, I haven't.
and they advertise their toxicity with bold patterns.